Hey folks, this is Tully and welcome to some more game dev. This morning we kind of revamped a bit of the layout of the first few forest rooms, and now that we've kind of got the dungeon castle area mostly kind of figured out. Still need to kind of rework some of the cutscenes, but I think we've got enough of a flow that we can start moving into kind of balancing some of the combat stuff. I made a save in between the first stream this morning and the second stream just so that we can start right at the beginning of the second forest room, right where we're going to have the very first combat. I'm pretty happy with kind of just the general layout. We'll replace all of these props when we get some of Trixie's latest stuff, but having it so that we encounter a slime here seems like pretty good in terms of like spacing and interaction. And now we've mostly got to figure out the tuning of some of this stuff. So this enemy's health is obviously way too high. Our damage numbers are maybe a bit too low. The enemy isn't doing enough damage. But I do think that like if we hit A fast enough, it's not too slow to kind of just wail on an enemy. It sometimes can feel like you should wait until all of this is done before performing another attack, but you can overlap them if you just keep smashing A. That's a polish feature we've been wanting to fix for a while, is to try and communicate to a player that you don't have to wait for the entire animation to complete before you can attack again. But I don't feel like it's too far off from what we're looking to accomplish with combat. We want to get it to be more complicated with performing combos, and hopefully that starts to look better when we start alternating between abilities, but for the time being I'm pretty happy with how that's feeling in terms of like just the animation, but the numbers need to be modified. I did want to take a look at where our damage formula is currently, because I think the last time we left off we were working on making it so, yeah, we had this kind of attack to defense ratio that we had worked into the formula. In fact, if we bring over this sheet here for the damage formula, we were working with this one here, and we had set it up so that if we change the attack power of the enemy, we can see how much damage a player would be taking at each of the player's defense stats. And if we change the defense of the enemy, we can see how much damage the enemy would be taking based off the player's stats. I am mostly concerned about the net change in terms of damage. I obviously want to be starting at a specific amount of damage that the player is taking. So if this player starts with 9 defense and the enemy has 11 attack, I think that's probably too high. Something like 9 attack, 9 defense is probably going to give us a closer number, something in the range of 15 to 20. But this was with this damage formula being based off of power, attack / defense. I'd also worked on a reverse exponential version of this, which is a little bit different. So instead of figuring out the formula via kind of this simple attack defense, we can bring up the formulas, data, named functions. So the simple version is simply doing a power factor to the attack value. So these current values we're seeing on this sheet is the factor is 1.1, so 1.1 to the power of the attack divided by the power of that factor to the defense. And if they're the same value, if attack and defense is the same value, this essentially works out to 1. Otherwise it'll be some number like 0.9, and when we multiply this, it like reduces the amount of damage, or if it's above a certain amount, it like increases the amount of damage by a certain percentage. Easier to see on this side, it goes up quite quickly. But I kind of didn't like the way that this was kind of essentially, it's exponentially going towards really large numbers very quickly as we get further away. But if we use an inverse exponential, we find that it kind of slows down. And in this version, I believe I even added a cap to the amount that this can modify. So if we go data named formulas, this kind of different version of doing this is more complicated, because we have to kind of do 2 different formulas depending on whether or not we have an attack that's greater or an attack that's less than the defense, because we can get into some imaginary nonsense. But essentially this is the part that we're really caring about. So instead of doing a power to a factor based off the attack, instead we do the attack divided by the defense minus 1 to the power of a factor. And this reversing of the formula allows us to get a more allows us to get a kind of really all it's doing is making it so that this starts as a bigger number and then slows down. We can see here that this starts at 22 and then becomes 136 and then 147. So here it's like a 22-point difference when we jump here, but here it's only a 12-point difference. And then from here it's 11-point difference. And so like the amount of increase that we're seeing is like descending, opposed to this version where the number is growing. Here we start with a difference in the value of 10, then 11, then 12, then 13. So it's increasing, every point is increasing the value. Whereas this version, although a more complicated formula, ends up with our damage numbers being the biggest impact and biggest change being when we are close to having the same values. I'm still not 100% sure this is exactly the way that I want this to operate, but this felt like I was getting more along the lines of what I would like to see. I'm just trying to figure out where is my actual factor value. Yeah, I need to figure out which values are which. And I would like to try implementing a variation of this in our damage formula, just to kind of get a better idea of which one I like more. But I like this spreadsheet a little bit better than what we had last shown on stream. So in this situation, we have factor as our first value, then attack, defense, that makes sense. Then our K value, which is essentially how much we're multiplying this value by. Yeah, and then we have a min and a max value. Okay, so I think this value here... Okay, so we've got B5 points to the enemy's defense. F9, F39 points to the current attack value that we're looking at. Actually, B5 is off. Oh, here's where the values are. These are just my favorite versions. These are, I tried some different numbers, but this is actually where the numbers are hidden. Okay, so B5 is the factor. So that's how much we're raising this to the exponent of. So in this case, it's 0.7. And then the K value, I believe, is the fourth number in this list. 1, 2, 3, 4. So that's this one. And kind of, we can see what effects these have. So if I increase this value to 1.2 from 1.1, these numbers get a little bigger. So if I change this number to be larger, the amount of gap between the first set of numbers increases. And then if I make this like 1, that changes this to be more even, it looks like. If I go 0.9, then there's a jump here of 14, then a jump of 12. Okay. If I 0.8, it's a jump of 17, then 31 to 0.30. So I think this number is changing how quickly we reach our large numbers, and this number here is changing how quickly we increase, and this is changing the initial impact of the very first one, how much of an impact we have. So if I go to like 2 on this to show an extreme version, then it's like a 0.4 difference, so it's a pretty big jump between these numbers. Okay. Yeah, I just like how much more control I have here. Here, I kind of just, I get what I get a little bit based off of some of these values that I'm changing. So I can change this one to be like 2, and we go pretty quickly exponential. Whereas this inverse exponential formula tends to give us something that we have a lot more control over. And again, my favorite values were 0.7 and 1.1. Those seem to be a nice jump here, so that there's a big difference between these 2 points and like these 2 points. But then the net changes more drastically. It's harder to see on the attack one because each point of attack is also increasing the overall damage. But really, if you just look at this column with 11, and I change this to like 2, you can see that that's an 11-point difference. Whereas if this is 1, it's much smaller. And in fact, it's even more apparent, I guess, if we look at the defense values. So here, getting a point of defense from 10, starting at like, say, I guess we're starting at 11. That's why this is highlighted gray. So the player starts with 11 defense. Then when they get 1 point of defense on the skill tree, they'll basically get a 2 damage reduction here. And if we were to increase this to like 1.2, it would be like a 1.2 damage reduction. 1.3, and it just kind of goes up a little bit. But 1.1 felt like a good rate of change here. If we went up to like 2, we could see that each point of defense would pretty drastically increase. If we change the enemy's attack value to something like 15, we see that like the point of like the breakpoint changes pretty heavily. So if we started at defense 11, an enemy would be doing 75 damage to us. But if we could just get a couple points of defense here, we would see overall like a pretty large change between these. You can't see a minus between them, but it would be almost a 30-point drop in damage just over a couple points of defense. I think I like it here though. That ends up being like a, honestly, still, oh no, it was a 40-point. I was doing my math wrong. I was flipping it in my head. Yeah, so this would be still a 30-point defense. So I don't know. I like 1.1. It feels like a nice rate of change as we get close to it. And 0.7 felt like a good spread until we reached the caps, essentially. If we were to uncap this, I'm less sure how to uncap this one. We would see that these numbers would grow more quickly, but I kind of like the idea that this is really more affecting a very tight range around the intended area I expect you to be in terms of stats. Okay, so let's implement this formula. And then we're going to want to make sure that the damage we're getting and receiving from the enemy matches what we're seeing in this spreadsheet. Because otherwise, if it doesn't, then tuning is going to be basically impossible. So it looks like we're doing something like this. So we're going to have to grab this whole thing, bring that into here. This should still be the attack defense value, which is just getting multiplied into the damage here. So it should still just exist. We can start this as a value of 1, and then if the attack value, which is going to be base attack in this situation, is greater than the defense value. Oh no, sorry, it's not base attack, it is just straight attack. And defense. Then we want to do this effect. Else we want to do this effect. Okay, now let's clean this up. The first one, well, they're both going to be plus equal to the starting value of 1. So this is going to be in Unity math f.min. And we're going to have a max value for this. I suppose we can make that a actual local variable for readability, attack to defense ratio. Now, this is all inside of the if statement, so the +1 is outside of it. So yeah, this max value is fine here, and the max value we had set in our spreadsheet was 1, which means, again, this all gets added to a base value of 1, so the max total can be 2. This needs to be mathf.power. This needs to become attack and defense. And then we need a factor still, which I believe can still be this value. And yeah, the big difference is instead of going that factor to the power of attack, we're going some ratio of attack and defense to the power of that factor. Okay, and then we need this kind of initial burst of change is going to be equal to this K value, which we started at... Oh, I might be getting these backwards, actually. Because we said the K value here is the fourth integer. Or fourth value, which is B6. So the K value is 1.1. Okay, so this is 1.1. And this becomes 0.7. And this old formula we're going to keep backed up here like so. We could separate these out into two different scripts, but I think this is fine. Okay, need to turn this into Unity Speak. Need to turn this into Unity Speak. And by that I mean change the syntax. This goes here, this goes here, and then we need a min value. Min attack to defense value, which we had determined to be negative 0.67. Again, remember this is tacked onto the initial base value of 1, so we're basically saying the minimum value we can go to is negative 0.67, which is essentially 0.33, is the minimum reduction we can have from this factor, or this ratio, or whatever you want to try and refer to it as. And I believe, fixing some brackets, that should be what we had in the Excel sheet with the correct numbers. Okay. So we're going to give that a shot. We're going to reset up the stats for the player and the enemy and make sure that they are showing up correctly as well. Let's fix this here. Okay. And then, is this... I'm not sure if my VTuber was moving correctly. Well, it is now. My avatar... We're looking for the file here. These stats are still hard-coded. I would like to make the design data for these again. It's something we used to have, but I have not updated in a while. We can hide these values. These should be fine to not see. We can hide this one as well. Okay, so... Oh no, we want that one up. So the player stats that we were originally thinking were going to be 7 and 11, and for the enemy we were thinking 10 and 10. So let's put the enemy back to 10 and 10. Let's go back to the player. We may adjust these depending on how they feel. Player's initial stats are not set here anymore, but are instead handled by the unit state. Persistent unit data. Here we go. And those haven't changed. That's still 7 and 11. No, sorry, 7 and 9. 11 is our magic attack starting value. It looks like I wanted a starting defense of 11 last time we looked. But if I was at 9, we would expect that the enemy with 10 attack would be doing 20 damage. Which is a bit high. What if we lowered the enemy's attack down to something like 8? That really reduces their amount of damage to us. 9? Then we could have a defense of something like 8 to start. And the first few points of defense could very quickly drop that damage output. Pretty noticeably too. If we start with 8 defense instead of 11 and 7 attack, then we'll be taking approximately 18 points of damage, plus or minus 10%. And each time we get a point of defense on our skill tree, that'll drop that damage by approximately 4, then 3, then at almost 2, 1, 1, and then very quickly diminishing returns versus this enemy. But then when we run into an enemy that has like 15 attack, that damage will shoot right back up again. Okay. I think I like that change up. Those seem like okay starting numbers. Reset that. Okay, so we'll start with 8 defense, and we'll start with the enemy with 9 attack instead. So we're going to go 8 defense. We can leave our magic defense a little higher, simply because we're not going to run into a lot of defense or magic-based enemies to start with. And so we can have this be a little bit of a higher stat, because it's not going to really affect the beginning few skill trees, I don't think. We may not even put magic defense as like a stat increase on the first few. Okay, and then back to the enemy. The AI will drop their attack value from 10 down to 8. Is that what we said? 9. Down to 9. Defense 8, attack 9. Okay. Let's give those numbers a shot and see how that's feeling, and checking whether or not that is... Number one, the damage numbers are matching our spreadsheet, and number two, do we actually like those numbers? So we're going to hit continue here. I have a save file on Forest TO2 from half an hour ago. Wow. Okay, took a little bit to go through the stat stuff. Honestly, it's a really good reference for even just myself in the future. Okay, so the enemy is going to walk up. We're going to turn. We're going to strike them with slash, dealing only 2 damage. And then the enemy did 11 to us. We didn't really check the values here. The enemy has a defense of 10, we said. And our starting power on all of our abilities are 10 as well, or at least it should be, I believe. So 2 seems low. We should have been doing closer to 4.5, so 5. 3, 3, 3. That definitely feels like we're a little on the low side for that damage. And then the enemy was doing 11 to us. 10, 10, 10. Does that sound right? No. We should be expecting to see closer to 18 damage to us based off these numbers. Okay? So something's off. Let's go debug our damage formula and see where we are going wrong. I'm going to guess it's going to be somewhere in that final formula that we just added, because everything else was working correctly with the old formula. So we're going to attach debugger. And we're going to see what we got incorrect. Like maybe we flipped a value here somewhere. Let's go back into Unity, enable debugging for this session. And let's give this a shot. Yeah, this stream is going to be very numbers heavy. I know people in the past have been curious about how you balance a JRPG. I don't know if this is the best way to do it, but it's how I do it. I like kind of just experiencing numbers and just being like, let's try and see what feels right. Which is a bit slower, but you could graph all of this stuff, and that's essentially what I'm doing with some of those charts. But so I'm kind of, I guess, doing a mix of both. I'm both graphing it out as well as kind of just getting a vibe for how much damage we're doing. So here our attack value was 7 and the enemy's defense was 10. Is that what we're expecting? Oh, was I flipping these charts? Okay, yeah, I think we're looking at this one first. So our attack value was 7. Our defense value of the enemy was 10. So no, I wasn't flipping, but I just got my head a little confused for a second there. But so we're doing an attack here. We should expect to see that we work out to a 0.5. This shouldn't have any randomness in it. It should exactly be 0.53 if we've done our math correct. And it is not. Okay. So something is different here. So this has a 0.7 there as the factor and 1.1 as the initial burst. So if we were to try and do this in chunks, will Unity tell us what this is? No, we'd need to break it down into individual local variables to get a better understanding. 7, 10. I'm wondering if I flipped something. I'm wondering if I flipped something. Let's go back over here. Okay. We're going to validate all these options again. So if we bring up the named functions, we open this up. The first value we intake should be the factor. Okay? So first value should be the factor. That should be a 0.7. And that factor is put in here. Okay? So if we come back in here, this value should be 0.7, and it is. Good. Then the next value should be the attack value, which should be 7. And I believe because attack is greater than or equal to defense, we use this one. Oh, do we get those backwards maybe? Attack greater than or equal to 7. We're using the second one. Seven, 10. That value. 7, 10. That value. Seven, 10. Yeah, I mean, I'm rounding a little bit in the main columns, but that should be coming out to be that. That is essentially the same thing. So we can see here more directly that this 5, 6 is 1.1. Okay. So my question is, which side of the if statement is being used here? If 7 is greater than or equal to... I would expect that this would be the part that's coming out to be true. Not a number. Okay, so it is using the second half here, which is also what we were seeing in here, was we were getting into this section of the formula. We'll validate that. But we're just going to check everything. Yeah, so we're getting into the second half here, which is the one that is essentially checking for a lower number. All right. So this is 1.1. This is 0.7. That should be this formula here. Is there a problem with brackets here, maybe? Let's break it down piece by piece. So we grab this part and separate it out and just do this solo. And then this becomes this part. And then let's break this part out here. Make that equal to this. Okay. Now we can kind of see each of the individual parts of the formula more easily, and we'll do the same thing in here to validate that we're getting the exact same numbers along the way, because something is wrong. And I'm going to assume something's different about the way the spreadsheet reads these formulas, and I would guess it's probably something to do with brackets in here. But I would expect them to be the same. Let's see, this is the power value, I guess. I don't know what to call these things. This needs to go here. That power value gets put into this call. In fact, I don't need to modify the end formula, I don't think. Power result will be equal to this using the power value here. Sure, we can do this as well. Okay. Put a breakpoint back in here. And we should be more able to see the differences between the formula in the spreadsheet and in Unity. Let's change things up. No, too ominous for that one right now. Very ice feel from this one. Sure. Okay, run into the slime. Enemy moves forward. We walk forward. We perform a slash attack. We get into here and we found the power value was 1. Yeah, that would be a very different outcome to 0.3. I'm sorry, how did you get 1? Oh, are these integers? Classic. Classic. Okay, yeah. So you can't divide by integers. because then they're just going to not be numbers that are floats, so you need to cast them before you divide. Classic Unity problem. Easy one to make. The amount of times that I have tried to divide two integers and then found at the end they don't work. The amount of times. It's like, why is it not being a fraction? Why is it not giving me incremental amounts that I can scale and modify, say, a progress bar or something on? It's like, nope, because you forgot to flip them to floats. Which is on me. It's working as intended. It's just intent is a little confusing to my brain personally. Now this is 0.3. Now the power result is 0.43 blah blah blah. And now the value is exactly the same number as the spreadsheet. Yeah, okay. So now let's reassemble this. I don't want to do all this local variable stuff if I don't have to. So we're going to just rebuild it all in here. Get rid of these pieces. Clean up the brackets because I find it easier to read personally. Then put this in here and this in here. All right, and then this shouldn't be necessary, that small chunk of code, but we're gonna just test to see if things are now working as intended. Got the both sides of the formula working as I want. Hit continue, load this up. So we should expect that with our current values, we should be seeing somewhere close to 4.4 damage, plus or minus 10%. And then here we should be seeing the enemy hit us for about 17. We're gonna just get past these debugs for now and just let the numbers be. So that was 4, 3, 13, 3, 3, 4, 13. So the enemy is doing a little bit less than what we would expect. 13 damage is a bit off. So we will give that another try and we will put the breakpoints back in to see what the numbers are working out to on the other side of the formula for the enemy's attacks. That feels more like the enemy is here. We're going to double check to make sure that we have 8 defense and the enemy has 9 attack. I'm pretty sure that is correct, but I want to be positive. So we should have 8 defense. Where did the AI beta state go? Did I close it? I thought it was pinned. It's up here. 9 attack. So 8 defense, 9 attack. Assuming this is physical, which all of our attacks are right now, that should be correct. Try this again. It's a slime. Okay, so yeah, we're hitting with that factor. Working out to somewhere around the range of 3. 5 point... Yeah, that should be fine. So we're doing what we're expecting here. But now for the enemy's hitting for a 1.25. If we go back into here... Let's increase the number of digits. 1, 2, 5... 6. Yeah, that looks to be the same. Yeah, that looks right. 1, 2, 5, 6, 5, 8, and then if we were to go even further, we'd probably see that 4. Yeah, so it's working out to the same formulas. But then the final damage here is 13, whereas the final damage here is much higher. So let's open this up and look at more of the details. So the defense applied value here, which is what we are multiplying by, because we take the T1, which is the power, divided by the power division factor, and then R7 here is this 11.3 defense applied. So let's check here. What was the defense applied here? The defense applied was different. Oh, okay. Is there something... Where's the difference start? Our defense ratio here is very close to 1. Let's check each of these formulas. So this base attack is 10.125. Let's start there. Base attack here is not the same. Ah. I don't think... Are we doing this? This is base attack. 10 defense minus... T2, which is our attack, to the power of 2 divided by 8. That's this value here. Then we add alternate attack, which in our current system is going to be 0. We're not doing any of that, but that's for if we have elemental attacks that are also physical. So if you're doing a combined attack that uses both the magic attack and the physical attack, you'd want to add a bit of alternate attack of the other type. But this one here, base attack minus 10 minus the defense divided by 2, I don't think we're doing that inside of our spreadsheet. Yeah, because this is 08. Where's 08 next used? Here. As part of defense applied. I think we've kind of gotten rid of this part of the formula. It just must not have been having a very large impact when we were doing this version. I'm going to validate that this also wasn't doing anything with that. It was not. So there was just a bug in the formulas, we just didn't notice it before. I'm going to I'm going to disable that, because everything else here should be fine. 265 minus the defense divided by 256. I believe that should be correct. Yeah, that's fine. And then here, this is the defense ratio to the power of the defense ratio times B4, which is this value here of 3 times the ratio plus B3, which is this odd defense factor. This formula is a bit crazy, but that is the same thing here. And then we times these two together, the base attack and the defense factor. And then we just apply this kind of attack to defense ratio that kind of normalizes a bit if there's too much of a difference between attack and defense. And then we just apply everything here. Okay, yeah, so I think this is an old formula and it's messing with our tuning from the spreadsheet to the game and making it so that they're not matching. So we're going to remove that and then try again. This is like the #1 most important thing when it comes to tuning stuff, is like if your spreadsheet, if evaluation of what should be happening and what's happening in game are different, you're basically never going to get anywhere. If you can't simulate it on paper, you're never going to be able to tune it. Has been my experience. You can't, okay, never is a strong word. You can do it. It's just going to be way more difficult than you would like. That's 4. That's 4. That's 15. 15's closer. 14. Okay, that still seems low. Let's go dig in some more. So attach the debugger again. And we're probably not seeing a big difference on the player's attacks because the numbers themselves are so tiny that there's not enough room for there to be a big difference. We should honestly do some kind of larger kind of stats to validate that this still holds up and is doing what we expect at the larger range of numbers as well. So this is doing 14, so this is 1.25, this is 11.3, that seems correct now. $11.309. Yeah, that worked out to be the same number. And that's a power of 10 divided by 8. And we are expecting a power of T1, so power of 10 divided by B1, which is 8, times this value and this value, so 11.039 times the S7, which is 1.25 something with extra values. Yep. And yep. So how come this came out to 14? Are we running into another integer problem? Power is an integer. And this is probably also an integer, so I don't think this is working out the way we would expect. I don't think we're getting enough. We're not getting enough because it's only dividing by integers, it's truncating some of it, so we're not getting enough significant digits. Wow, that's been a problem for a while too. Anywhere else that we're doing that? Float, float, yeah, all these are floats. Yeah, okay. I missed some of that. Let's just take away the breakpoint for now. I think that was a 15 again. 3, 4, 3, 15. $15 still seems low. We'll try converting this to a float too to make sure that that's not a problem. Probably too late for that. Okay, cool. All right, well, here we go. Come on. Be the same numbers. Because once we validate that the formulas are working out the same, then we can go and actually start the actual balancing process. But until the formulas are the same, we can't. Slime. Oh, that's a little higher. Because we are expecting 4.4 to 5, and there's 17. And there's 20. Does 20 make sense? I think so, because we do a little bit of an additional times value somewhere in here. Because we output this damage value, but then we times that damage value by 90% or 110%, so there is a bit of a range. So 20 probably is still within that range, and then 18. And I do believe it was closer to 18. Yeah, 17.8. So I think 20 seems reasonable. I'm going to validate that the final number is exactly what we would expect there, though. Because this damage value at this stage should be predictable, and there should be no variance or randomization there. And so we should be able to make sure that is always the same and matches the spreadsheet every single time. And we'll do that same for our attack as well. Damage of 4. I guess we are rounding this to an integer. Huh. We gotta truncate at some point, though, because these do need to be whole numbers. But would we prefer to maybe finalize the number to an integer here? I'm not sure. So I guess realistically, to make the spreadsheet match, we'd need to truncate. Because we're doing a... Well, no, we're doing a round here. So we probably should be rounding all these numbers in the spreadsheet to make sure they are the same. So then the enemy's going to hit us, and it becomes 18. Because we're rounding up. And then we add a bit of damage on top. Okay. So we should do a round here. And then we can get rid of the decimal points. But we do want to not... We don't want to do that just by the spreadsheet. We do want to add the round to everything. And now our damage values will be exactly the same. And we'll do the same thing over here. So final number gets rounded in the engine, so it must be rounded here as well. And if that's the case, these all become whole numbers of net changes as well. We can hide these columns because we're done debugging. Okay. Now we stress test the damage formula. Let's change the enemy attack to 155 with a power of 50. And then let's check what happens if the player has 150 attack or defense. So 150 defense versus 155 attack. So we'll come into here, we'll give the enemy 155 attack, and we will give the player 150 defense. And we will need to modify... Well, it's kind of annoying to modify the power value, but we probably should, just to make sure that this is every facet of this changing is correct. Let's stop debugging for now. We're gonna have to go find the power of the enemy's attack. Is it this one? Or is it AI attack? Where's the enemy? I don't remember. I believe it's this one. And they're using AI attack. Okay. So it is this one, and then we need to make sure the power is being set. And it doesn't look like we even do that. How does that work? If there isn't a power value, I believe we get somewhere along the way we make it default to 10? Where does that happen? If it doesn't find anything here, it defaults to 10. So I guess the easiest way for the enemy is just to change this value here for testing purposes. And that should give us the numbers, and we're going to validate that this works out formulaically to the exact same value as the spreadsheet, even with much larger numbers. Try that again. It seemed to have froze. Okay, now we're okay. Oh, it's thinking again. Sometimes it gets so mad about debugging. Can I have control back? I can have control back, thank you. And then we will put this back here to see what the final number is before modification. Okay, this is fine. And we skip here, and we should see 3863 as our damage number. And in the spreadsheet, we expect our damage at 150 to be 3863. Yep. That looks correct. So we can also try to going to our largest extreme. So we can go to 100 power with a 255 defense and a 255 attack, which is the largest numbers we'll get to in our game. Right, of course, the enemy kills us one hit. Okay, we'll run it again, and what are we gonna get? What are we expecting? If we change our power to be 100, which is the highest power we can get to on an ability, and then 255 on the enemy's attack. If we have 255 defense, we expect that the damage we take will be 9,662. Right. should still be debugging. Skip our turn. Enemy hits us for 9,662. Okay, so these formulas are now giving us the exact same numbers, whether it's coming from our spreadsheet or being calculated in-game. Here we want it to go back to 8, I believe, and here we want to go back to 9. Okay. So we have validated our formulas are working as we expect. We have validated across at least 3 sets of ranges, a low, middle, and high kind of numbers that they are matching across the formula. Now the question is just, what do we want the numbers to actually be? In just kind of testing the stuff, I feel like it's a little weird that we're dealing 5 damage to the enemy, but the enemy is dealing so much more to us. But at the same time, we move 3 times and the enemy moves once. So it kind of works out to be somewhat even. Probably the more important question is, how much health do we want to have? Also just want to check if we do like 18 times 1.1. Yeah, I guess that comes out to a number that rounds up to 20. Okay. I'm just making sure 20 is a valid range, and it is. So the enemy hits us 3 times and we die because we only start with 45 health. We could start with 9 defense instead of 8, so that we only take 14, which would significantly decrease the amount of damage we're taking. And then each point of extra defense would be 3, 2, and 1. Is a 3-point drop we could also lower here so that the enemy has 8 defense and we have 7, or sorry, the enemy has 8 attack and we have 7. Again, as long as we keep the point value where the enemy is 1 point higher than us, then that first point of defense that we gain in the skill tree will have a fairly large increase. And then the next point after that will have another pretty large increase, because this gap is going to be at its largest in this specific range. And then it'll kind of have diminishing returns after that. But this would allow us to have like a 4-point damage decrease and then a 3-point damage decrease, and then it kind of drops down to like 1 as we kind of continue from there. I just want to have taking defense stat nodes feel impactful, or at least as impactful as taking damage nodes. Something that I notice. And that's why I feel like 9 and 8 makes sense to me, because I feel like taking 18 or 20, depending on range, from the enemy feels like a lot. It's like, wow, I'm taking a lot of damage from these enemies. And then when I drop down to 14, I feel like I might notice that more. I would go back into combat and be like, oh wow, okay, I'm taking like 25% less damage now. Or I'm taking, yeah, the damage they're doing is 25% reduced. I think that's a more accurate way of saying that. And my hope is that as a player, I would notice that more. But if it's 8 and 7, this would still be a drop from 15 to like 10, and depending on range, it could even be like 16 to 9 at the widest margins from like the highest cap and the lowest low. If we keep going down and we say we start at 7 attack but only 6 defense, then we'd probably be taking somewhere in double-digit range, and our first point of defense would drop that below. Sometimes. Not guaranteed, but... Because, yeah, here, this would have a range of probably somewhere between 11 and 10. I guess that's maybe something we want to know, is, like, what is the range of damage here? Which is going to be 2 columns. So that's going to be... this value times 0.9 rounded. Not going to autofill for me here. Unfortunate. All right, to the bottom. I think most of the time we can kind of minimize these, but in this particular situation, we would expect to be taking somewhere between 11 and 13 damage with these stats. And then the first time you get a point of defense, you would go down to 8 to 10. The question is it more noticeable dropping below double digits, or is it more noticeable dropping from, say, here to here? I guess with the min-max range, there is a chance that you end up being pretty similar. You could see yourself getting hit for 16 and then unlucky and seeing yourself hit by 15, so it would only feel like a 1-point damage drop. Even though it's a much bigger average damage decrease. Whereas if we're here, you could still see that only 1-point damage decrease. I wonder if that's a consistent thing. It doesn't look like it. We gotta kind of just pick a lane, because depending on how much health we give the player, they could survive a number of these hits anyways. Six is too low. I feel like this is probably an okay starting point. You start at taking 11 to 12 from an enemy, and you're dealing about 4, but you can attack 3 times. So they end up being similar numbers. Let's play it in game and see how it feels. So let's change the player's defense to 6. And the enemy, what did we say? The enemy here we want to have 7 now? Is that what it was? Yeah, 7 here. And then for the player, we want to have a defense of 6. And this doesn't even factor in like if we want to have like a speed stat or something that modifies like dodge, which is a much trickier stat to represent because the player won't feel the change very often. That actually feels pretty good to me. When we were taking 18, it felt a little bit more punishing. The other question is how much health do we want to give each other? If I'm hitting the enemy for approximately like 8 on our first attack because we have to move up to the enemy, eight to 9, then we take 12, and then on the backswing here we can hit them 3 more times to deal somewhere in the range of 12 to 15. Giving them about 20 health feels like it could be pretty good. Complete gut, but I feel like 20 sounds right for the enemy. Max HP of 20, starting health of 20. And then for the player, if we're taking 12 per hit, we probably want to get hit by an enemy maybe 5 times. And then maybe just give you 5 extra hit points for variance to survive 5 hits and be very low on health. And then we get into the tricky part, which is when these numbers start changing. So now we need to figure out if this feels good. It's like, okay, well now after a run, how much experience have I gained on my skills, slash, more importantly, how many skill points have I unlocked by leveling up my skills? And what stat nodes do we have near the beginning to kind of really make it so that we feel the impact of this? Okay, defeated that enemy. That felt okay. Walk into the next room. Does involve hitting A 5 times to defeat an enemy, which isn't super crazy, but this is also the very first enemy we're fighting. Ooh, we pop up when we attack. Did I not fix the positioning of slash very well on that one? Interesting. Here we get an auto tutorial on clearing darkness, which is kind of interesting. That's where we'd first gain the power. Oh, I don't have some of the cubes underneath the room tile. That's unfortunate. Health bars are disappearing off the enemies. And this last enemy will get the kit and take us out. Okay. So how many levels did we gain on our weapon for that? 6. So we could get strength, a health increase. We get strength, defense strength, and a speed increase, which I don't know what that does right now. So almost the entire skill tree unlocked on the very first run. We might want to decrease the amount of experience you get per swing. I'd also still like to show the amount of experience you're getting in some way. Yeah, I mean, what were our stats? How much did we just increase our stats by? We went to 11 attack by going 1, 2. That one's worth 2. So yeah, we gained +4 strength. So if we take a look at the sheet, we went from dealing 4 to within the range of 25, basically, which is enough to one-shot an enemy. So maybe a little too much attack stat in the skill tree right now. Out of curiosity, if we were to replace that +2, so we would have had 9, right? With a +5 power to that slash attack, what would that have done? We would have been doing about 16. So it would have been more damage by about 5 points, but it wouldn't have been a, like, 10-point increase. Yeah, so getting +2 points of strength here at this particular spot is pretty huge because you're overcoming... Yeah. So same thing was happening over here, because anytime you're kind of going up and over the kind of enemies valued a stat, basically, you're kind of going over this section here where it goes from like the one before 1, the one where the numbers match, and the one just after that is when you'll have the biggest net change. So yeah, over the course of going from 9 strength to 11 strength versus these enemies, you'll get a pretty huge increase in damage output. Which is fine, but I think I'd rather see us not get so much strength on that ability, but have that node that's up behind the defense give a +5 power to the ability instead, which will still be a damage increase, but it'll only be a damage increase for that skill opposed to a global change in the power level of the player. And then we'll be able to two-shot an enemy from this point, guaranteed. Are we two-shotting an enemy from this point? Yes. So the power increase doesn't really make much of a difference. Sour Patch Kids in YouTube chat saying procedural block generation for every zone might be annoying for gameplay. Looks good so far. So there is no procedural block generation. The maps are fixed. I guess the question is, what do you mean by procedural block generation? If the thought is that the game will have the world be different every time, that's not the intent. The intent is that the world is the exact same, and every time you come back in, it is the same map. And the more you explore and reveal, the more you'll be able to kind of know where to go. But it's more of a dungeon crawl experience than like kind of a procedural run type thing. The part of the idea is that as you get further on and you gain more stats, you know the direction, you'll be able to much more easily get to the next checkpoint. And once you reach a checkpoint, then you'll gain access to essentially another area to start exploring. And every time you 100% complete a zone, you gain more maximum time, allowing you to also gain more progress that way. If you mean procedural block generation in simply the idea that like you have to walk to reveal the world, that I agree could be annoying, but I'm trying to get the speed of that to be quick enough that it's never an annoyance to reveal each next section. I feel like the 5 power or the 5 HP from the stats doesn't feel impactful enough at this range. The enemy's doing 9 damage to us. Does that also match what we expect? Yeah, because we only got 1 point of defense. So that's the exact scenario we were looking at earlier. So yeah, we went from having 6 defense to 9 defense. Okay. Okay. Not I'm not too how do I put this? I think I'm pretty happy with where these numbers are currently. I'm not sure about the net change in them, but I think that they're probably a good enough starting point to just assume that this is what our base stats will be, and then we can start tuning the skill trees and the abilities. I think I'd like to have it so that the enemies aren't going from 5 hits to 1 hit. I think the biggest way we're going to be able to control that is by changing the amount of defense, or sorry, the amount of experience you gain per hit. Because each time you slash, this progress bar increases, increasing that skill's skill points, and then each skill has its own skill tree. I think we're gaining too much experience too quickly, at least on this first run. We did have a task that we wanted to try and pass that experience down. Into the ability, because right now I think it's hard-coded amount of experience, but I think we should do some calculations to determine how much experience you should get. Okay. That's probably next steps then, because we can't really balance the skill tree until we know how much experience you're getting per run. Let's take a look at how that's operating. Let's look at slash. So if we deal damage and we defeated the enemy, we're getting 50 experience. If we didn't defeat the enemy on the attack, we gain 30. And if we miss, we gain 15. So if an enemy takes 5 hits to kill on the first run, and the last hit will kill them, then we're gaining 180 per enemy that we fight. And if we get a miss, it's kind of like a bonus 15. Yeah, and then we're currently killing 2 enemies guaranteed and potentially a third. Yeah, it's too much experience. I think I'd also like to have these numbers appear when we're hitting the enemy, but there's already the damage numbers flying off. I don't know if I want to have another number flying off at the same time. And this is our smallest font we can have with our pixel size right now. So if we were to have a second number, it would be the same size. Yeah, so we would have to have it so that we hit them, deal the damage, and then we might have to have a little bit of a delay with like the number flying off, but then if the enemy attacks us, it's going to happen immediately. The other option is we have the number appear over here as the bar increases, but I think that's going to distract from the action. We could try and have the experience for each skill gained when like the slash name comes up, maybe, but we give you experience based off whether or not you hit or miss. So you kind of need to see the number appear for what actually happened. It's like part of the problem is like this tension I want to have between like I want combat to feel quick, so if I hit A quickly enough, I should be able to like spam attack basically. But I also want to like display kind of a standard tactical information, which is usually quite slow because you have to put so much information on the screen. But like if I keep hitting A over and over again, I can actually slash pretty quickly. More quickly than it actually would seem, because you don't have to wait for the ability to finish. I kind of have it so that you can hit A again while the enemy's damage numbers are flying off. And that's not even getting into like combo points. We have like the combo system for if we have multiple skills, we can unlock and do combos against certain enemies. You know what, let's see what that looks like actually. What does combat look like if we have our combos? Continue. So if we come here and then kill this enemy. What are you mad about? This has just happened recently. I think something about my custom editors, it is very upset about. Is it this one? I don't know what all those errors are. It's upset about something I'm doing with my custom editors. It's not to do with the actual game, it's to do with my tools. Okay, let's debug and the run. Let's unlock these two abilities. Okay, let's equip all of our abilities and let's go into combat with a full set and see what that feels like. They're all effectively identical because they all use physical attacks, so they're all going to use the same attack stat, and they're costing the same amount of action points. Oh, we still have the bug where our health doesn't reset if we don't die. We should fix that. So I can shoot and then move away, shoot, shoot, move away. I can pretty easily kite an enemy. Or if we want, we can come in and engage an enemy with, I think it's bash slash bash. Oh, that kills them before we even get a chance to do the full combo. That's without any stat increases either. Just the increased power level that you get from performing a combo. Interesting that enemy didn't alert immediately. Yeah, without any stat increases, just gaining bash and slash to be able to perform our combo type attacks on this enemy makes it so that enemy is easily defeated. Maybe we want the first enemy you run in here to be really squishy. Like, maybe we shouldn't even be using the slime as our first enemy. Maybe we should do like a little tiny blob version of them that's even smaller to indicate how weak they are. And then we have a slightly bigger slime you run into that we can have the stats increase on. Yeah, because this one has like eyes and stuff. Maybe we want something that's even tinier. That's more of like just a droplet. Oh, I went backwards. Oh. What did we do there? Oh, that's a fun bug. So what happened there was we walked into the room, and on the end of the turn, the enemy should have went and been alerted. But because we left before the enemy had a chance to alert, it then didn't try and do the alert until after we came back in. But when we came back in, the alert icon it was trying to play on that enemy wasn't going to work because that enemy was from our previous version. And so it couldn't perform it. Interesting. So we might want to clear responses when we switch rooms. Oh, we're going to debug, just unlock these. Just want to see what it feels like to play with these. Probably should make another save file so it's easier to kind of get back to the state. There isn't really a lot of reason to choose one ability over another right now. Beyond, like, potentially which one you want to gain experience with. But that'll come a little bit more once we have different enemies with different combo types. So you might want to do, like, a B attack versus things that are weak against the B attacks, or Y against things that are weak to the Y. And that'll kind of change up a bit of it. And it's also possible you might want to have bonus experience for performing combos as well. so you get more experience for using the right ones. Text flies off weirdly if the enemy dies, which is also not great. And even with like a fair amount of experience and stats, we're still not able to make it to the end of our run in time right now. So some of the spacing on the rooms is maybe a little bit off, but we also haven't implemented the goddess time increasing. We also need to change it so each of these have a different skill tree, because right now they're just using the same template. So we need to kind of variance that. It's all data entry at this point. I'm happy with these damage numbers. I think there's a real chance that we might want to have the first few enemies be like baby slimes, so that they have like 20 health and they're not too hard to beat. But after you get past this little tutorial area, you run into these enemies, which actually have like the eyes and are a little bit bigger, and maybe they have like 50 to 75 health with some increased attack and defense. So it becomes more of a wall that blocks you from moving forward. Yeah. Because I want the stat improvements to feel impactful, which is a lot of what we've done with the damage formulas, but it means that we do outgrow enemies very quickly just with a couple points of stats. Being off number can have a real big impact on how much damage you're taking or receiving. So if you are out of your depth, you are going to get stomped, and you need to kind of grind a little bit to catch up, I think might be a result of that. Yeah, and with the current layout of time, we just don't have enough to get there. Maybe, actually. 16. The goddess statue before we deleted all the props was close to here, so we might be able to reach it. Okay, so yeah, as we improve, we might be able to just do enough damage to enemies to kind of one-shot them, which gives us just enough time to reach the goddess statue. Interesting. But I think even just having, like, revealing a couple of these rooms give you a bonus 15, like, seconds or minutes, I haven't decided what these units are, would probably also give you more than enough time to get there. Okay. Cool. I think I'm in a good spot to call it here for today, though. We're a little early. We normally go until 4, but I'm kind of happy with the progress we've made, and I think I just need some time to think. We've only got 2 more days left. I might do a stream with Drixie tomorrow, or I might just take tomorrow to just like focus and let her do her art thing, and I'll quietly just kind of work through some stuff as well. I don't know. I'm just not sure. So keep an eye on Discord or the schedule for Twitch. And then Sunday's my last day of vacation. We've been off for 4 weeks trying to get to the point where we can have a demo. I don't think we're going to get to the demo where we currently are. We're so close, but I think there's just a lot of data entry. We need to come up with text and dialogue for a lot of the cutscenes. There's a lot more tuning and skill tree building that we need to do. We still have some features we're missing, like gaining time when fully revealing a room. I don't think we're going to get there. But I think there's a good shot that by the end of Sunday, we'll probably be in a good spot where it's just data entry for us to get to the demo. And then we'll probably have the demo released somewhere mid to end of January. It's going to depend on how like ramping up on real work goes again, because I don't fully know what I'm up to once I come back from this long vacation. Not sure what the next project is for me, and depending on some of the projects that I could be put on that could brain drain me from being able to work on this side project as much. Yeah, okay, we'll come back for sure Sunday for the final day. If not, we might be back tomorrow. Or if not sooner, we'll be maybe back tomorrow. Yeah, because we didn't get to combo points. We have not fixed the checkpoint screen up. We haven't figured out how, like, changing music works when combat starts, because combat starts basically as soon as you enter a room and you reveal an enemy. I do have selecting the first ability finally done. We do kind of have we've kind of completed another pass on the tutorial maps. But we did intend to build, like, we're here. We've done the Demon Castle here, and we've kind of got a rough template for these ones. And we're just barely making it into this room, and we wanted to build this whole section as well. There's no way I'm getting all that done by Sunday. We wanted to potentially add items requirements to unlocking certain nodes, and then like treasure chests that would give you those items. We had talked about building an option screen for movement controls, because some people like diagonal 45s on the joystick, some people like up and down on the D-pad. So like we might want to have options, or we're gonna want to have options. There's a couple of different enemy bugs. The combo point system needs refinement. It's not clear enough. Like to do an audio pass. There's a level up text we talked about. HP being low isn't super clear. It's not easy to notice. Not clear when you can perform another action. It feels slow, but mostly because you don't realize you can attack again right away. Never even got to the skill points on the UI being useful in any way. And then there's a bunch of like smaller kind of little things. Add more narrative cutscenes after each run. When we talked about that experience stuff, there's just a lot, and we didn't even get to some of the stuff we wanted to do originally. We did do a lot of actual like completed work. It's been a really amazing 4 weeks, but just didn't quite get to everything. The big thing is the map editor, though. I feel like getting the map editor to the point where it is now, it's just so nice to be able to build maps so quickly. I'm gonna speed up through this tutorial. And I think once we've fully kind of decked an area out, I'm really liking the vibe and the experience of a lot of these zones. Yeah. Yeah, it's a lot of progress, but at the same time, it's also not enough progress. Yeah, there's bugs around the animation for this too. A lot of bugs around this thing. Okay. Okay. I think Sunday probably should be a review. I think regardless of where we get to on Saturday, I think Sunday should be maybe a little bit of polish in the morning, and then just a review of everything we've done. And maybe scheduling the next month for just like only working on the weekends probably. What can we expect to accomplish once we're no longer on vacation and having all the time in the world to focus on the side project? It's so close to being a video game. Okay. Yep. Enough lamenting. We will be back maybe tomorrow. Maybe tomorrow, but definitely Sunday. We'll keep working on it, even if we don't get it done for the deadline. We will just build forward step by step until we have the demo, and then hopefully get some feedback from people when it's actually like in their hands. I think that's going to be super valuable because you can't really see how it's controlling right now. And yeah, for now though, this is going to be Tully signing out.